All right, folks, if this one's long, I'm trying not to. Just a couple of things I need to make sure that you see, because these are kind of questions that you would see on something like the SAT. It kind of breaks things down, finding a probability of portions, especially using geometric figures. All right, you throw a dart at a board. If you've ever played darts, it's a square, usually has some outliers, but then the actual dartboard is a bunch of circles that get smaller. Okay. Your dart is equally likely to hit any point. That means when you throw it, you're just as likely to hit any one point as another. Are you more likely to get 10 points or 0 points? Now we got to look here. 10 points. So 10 points is this circle right here in the middle. And 0 points are these outlier areas here. Now I'm accidentally going a little bit in and out there, but that's because I got a thick old highlighter here. But you get the idea. So it's asking, are you more likely to hit the bullseye or miss the circles altogether? So what we're going to look at here is, first, we're going to look at the idea of the probability of hitting 10 points. In order to find that, we're actually going to have to take the probability of hitting the entire, or not the probability, we're going to have to take the entire board into account, but then only look at the smallest circle in the middle and how much it takes up of the entire board. So, in other words, we got to find the area of a circle and we got to find the area of a square. So we find that the inner circle has a radius of 3 right here, because we can follow this line and follow it to pointing between a center line and its edge, which is the definition of a radius. And luckily, the area of a circle is pi times radius, in this case 3 squared. Then we can use the entire length to understand that the length from center to edge is 9. So the radius of the big circle is 9. But that means that the side is 18 because the side is equal to our diameter and our radius is twice our diameter is twice our radius. Now, that means up here that the total area of the whole board is 18 squared, because the total area of the whole board is the square. The square has a side A, or side 18, and it's side times side, so 18 times 18 is 18 squared. The area of the small red circle was pi r squared, which had a radius of 3, so pi times 3 squared. All right, so that leaves us with 9 times pi. And let's see, 18 times 18 is 324. So when we simplify that, that means it's pi over 36, and that is about 0.0873, or 8.73%. So the chance of hitting a bullseye is 8.73. All right. Now that I have the probability that I'm going to be able to hit 10 points, now I have to find the probability I'm going to hit 0 points. It's not as bad as you think. So if we take the area of the outside the largest circle and the area of the entire board, well, the area outside the largest circle would just be the area of the square minus the area of the largest circle. So we already know the area of the square was 18 squared. So then we have to subtract the area of the largest circle. Well, the radius on the largest circle was 9. So I need to take and put in 9 for my 9 squared here. Now I'm comparing this, or dividing it all by the area of the largest circle, which was, again, 18 squared. So if I go through and I actually punch all these in, I get 324 minus 81 pi over 324. Now, when everything simplifies, I get 4 minus pi over 4. Trust me. Because 81 goes into 324, I can take that out and cancel in the denominator, and I'm left with 4s. That's how that works out. So that ends up being 0.215. Or 21.5% chance I'm going to hit 0 points. So which one is more likely? Well, 21.5 is bigger than 8.73, so I'm more likely to get 0 points than I am 10 points because there's more area that's worth 0 points than there is area worth 10 points.